In today's video, we're going to be building a classic Pong game with a simple AI component. We'll be using HTML, CSS, JavaScript, and a little bit of NodeJS. So let's get started. So the first thing we want to do is open up our favorite code editor. Mine is Visual Studio Code. And then we'll open up a terminal. We just want to run npm init-y. And that's just to initialize a new node project. Next, we're going to install two packages. That's going to be Express and Socket.io. So we run npm I express and socket.io. Once they're installed, we're going to create a folder called public. And inside that public folder, we're going to create a file called game.js and also index.html. Outside of here in the root, we're going to create a server.js file. So these are the only three files that we're going to have for this project. And we can see inside our package.json file that we have Express and Socket.io installed. So inside the server.js file, we're going to create a quick and simple API. So const express is equal to require express. Const http will be equal to require http. And then const socket.io is equal to require socket.io. Now we can initialize our project. So we say const app is equal to express. Const server will be equal to http.createServer. Const io will be equal to socket.io and then the server. And we want to create a static folder. This static folder is going to be our public folder here, and that's so we can access these via the API. To do that, we say app.use express.static, and then we're just going to have public inside of there. And once that's done, we can say server.listen. And listen on port 3000, and we just console log out that the server is running on port 3000. So we can click save, and we can run node server at the bottom just to check that that's running. And you can see that the server is running on port 3000. Also at this point, if we go to the index.html file and just type in hello world, and then inside of our browser, we navigate to localhost 3000. We can see that we can access that hello world inside of here. So with that done, we can start adding the content for the index.html file. I'm going to copy and paste in and explain what's happening in here. So we're opening up our HTML tag. We have a head. Inside the head, we have a title and styles. The styles is just for the canvas. We've got a black background on the canvas. It's going to display as a block, and the margin is going to be auto, so it sits in the middle of the screen. And inside the body, we're going to create a canvas. The canvas has an ID of Pong, a width of 800 pixels, and a height of 400 pixels. And then we import the socket.io script and also the game.js file that we have here. So with that done, if we refresh the browser on the front end, we should see we have our canvas in the middle here. So with the index.html file set up, we can close it, and the server.js file we can close. And now we're into the game.js file. This is going to contain all the information for the actual Pong game. So first off, we want to create a few constants and a few variables. Let's start off by grabbing the canvas. To do that, we say const canvas is equal to document.getElementById, and our canvas has the ID of Pong. And then we want to get the context of the canvas. To do this, we say const ctx will be equal to canvas.getContext, and we want a 2D canvas. So we want to be able to keep track of the scores for each game. So we're going to say let scores be equal to an array, and it will just be 0, 0. And we'll update that when the ball goes off the screen. So next up, let's define the ball. So const ball will be equal to an object. I'm going to say x will be equal to the canvas.width divided by 2. Y will be also equal to the canvas.height divided by 2. The radius will be 10. Speed will be 4, dx will be 4, and dy will be 4. So the dx value establishes whether it's moving left or right, and the dy establishes if it's going up or down. Up next, we're going to declare the user paddle. And that's going to be equal to an object with an x of canvas width minus 20. That's so it sits 20 pixels in from the left-hand side. And the y is equal to canvas height divided by 2 minus 40. So it sits in the middle. We do the minus 40 because our paddle is going to be 80 pixels high. And the width will be 10. And the height, as mentioned, will be 80. Then we'll have a dy of 4. So now that we've established the user paddle, let's now establish the AI paddle. So the const AI paddle is an object. We'll have x is going to be equal to canvas width minus 20. Y will be equal to canvas height divided by 2 minus 40. Width will be 10, same as above. Height will be 80, and the dy again will be 4. Now we're going to create a function which will allow us to move the paddle. So move paddle. And that will have the paddle as a parameter and the y as a parameter. So in here we're going to say the paddle y is equal to y. I'm going to say if the paddle dot y is less than 0, then paddle y is equal to 0. And then we'll say if the paddle y plus the paddle height is greater than the canvas height, then paddle y will be equal to the canvas height minus the paddle height. And this is to ensure that we can't move the paddle off the top or the bottom of the screen. So up next we have the move ball function. Now this is a large function, so I'm going to paste it in here and then go through what the actual code is doing. So we have our function move ball, and then we're going to say that the ball.x plus equals the ball.dx. So that's the motion of the ball that we set above. And ball.y is plus equal to ball.dy. That was the left and right one we set above. And then what we're going to say is if ball.y plus ball.radius is greater than the canvas height, or ball.y minus ball.radius is less than 0, then ball.dy is times equal to minus 1. So up next we have two if statements. The first if statement is to do with the user paddle, and the next if statement is to do with the AI paddle. And this is to see if we have collisions on the paddle. So here we say if ball x minus ball radius is less than user paddle.x plus user paddle.width, so if it hits the user paddle, and if the ball.x plus ball.radius is greater than the user paddle.x, then the ball.y minus the ball.radius is less than the user paddle.y plus the user paddle.height, and the ball.y plus the ball.radius is greater than the user paddle.y. So if that's true, then what we're going to do here is ball.dx times equals minus 1. We're reversing the direction of the ball on the x-axis. And then what we want to do is we also want to increase the ball speed, so it makes it more difficult the more times the ball is hit. And then we get the collision point, so we say let collide point is equal to ball.y minus the user paddle.y plus the user paddle.height divided by 2. Then we want to get the angle at which the collision hit. So we say angle rad equals math.pi divided by 4 times the collision point. And then we can set the ball dy to be equal to the ball speed times by the math.sin and then the angle. So we're returning it back at an angle with a slightly higher speed. Then we have this adjust AI target function here, which we'll write in a second. Then up next we have this if statement, which is to do with the AI paddle. So it's exactly the same as the user paddle, apart from every time we mention user paddle up here, we switch it to AI paddle. And then in these two if statements, what we're doing is we're saying if the ball.x plus the ball.radius is greater than the canvas width. So if the ball goes off the right hand side of the screen, then we want to increment the 0th score, so the player's score, and then we're going to reset the ball. We'll write that function next. And then if this one happens here, so if the ball.x minus the ball.radius is less than 0, so if it goes off the left hand side screen, we're going to increment the second value in the scores array. And then we're going to reset the ball to 1. So that was the largest function here. Up next, we've got the reset ball function, this one here. So let's say function reset ball. That's going to take in a direction as a parameter. And then all we're going to do here is reset the position of the ball. So ball.x is equal to canvas.width divided by 2. Then the ball.y will be equal to canvas height divided by 2. And then the ball speed will be equal to 4. I'm going to say the ball.dy will be equal to math.random. We're going to see if that's greater than 0.5, then we want to return 1, else we want to return -1, and then we're going to multiply that by the ball speed. And then the ball.dx will be equal to direction times the ball speed. So let's now write the AI adjust target. So function AI adjust target, or adjust AI target, sorry. I'm going to need to set a variable before this called let AI target y. That'll be equal to canvas.height divided by 2. Then inside here we can reset that to AI target, and that's going to be equal to ball.y plus math.random. I'm going to times that by 60 and then -30. So with that done, we can now look into the AI logic. So we'll say function AI logic. We'll say if the ball.dx is greater than 0, then we're going to adjust the AI target. And then if the AI paddle dot y plus the AI paddle dot height divided by 2 is greater than AI target y, then what we want to do is we want to move the paddle. It's going to be the AI paddle, and we're going to move it by AI paddle dot y plus AI paddle dot dy. Else, we want to do that in reverse. So this will move it down and this will move it up. So we're close to completing this now. We have a few more functions to create. So we're going to have a function called update. And this function is just going to take in some of the previous functions. So the AI logic. It's also going to take in the draw function, which we'll create in a second. And then we want to request the animation frame. So request animation frame. And then we'll pass back updates into the animation frame, just so we're constantly updating. Next off, we want to listen on the canvas for the mouse movement, so we can actually move the user paddle up and down. So to do this, we say canvas dot add event listener mouse move, and that's going to return an event. And we say let rect is going to equal canvas.getBoundingClient rect. Then let y will be equal to the e.client y minus the rect top. And then lastly, we want to move the paddle. So move paddle. We want to move the paddle by the user paddle. then y minus user paddle dot height divided by 2. And then we can close this off and run update as a function here. So now that we have all of that done, we can actually start drawing the content onto the canvas. So I'm going to paste in a piece of code here above the update. I'm going to talk through what's happening in here. So the function is called draw. We're going to set a font size for 30 pixels in Arial, text align center, and text baseline is going to be middle. This is for the text for the scores. Then after that, what we want to do is we want to clear the contents of the canvas. And then we're going to set a CTX fill style of white to the text. And then inside the rectangle, we want to draw the user paddle. So we're going to create a rectangle with the user paddle.x, user paddle.y, user paddle width, and also user paddle height. And then the same for the AI paddle. And then we can begin to path the ball. So we say ctx.begin path. Then we say ctx.arc, ball.x, ball.y, ball.radius, then 0, and math.pi times 2, and then the last one will be false. Then we want to fill style that with white, so the ball will be white. And then we do ctx.fill. And then we want to start writing our actual scores on the board. So ctx fill text, and that's going to be the player score, dot canvas width divided by 4, and then 30 pixels down from the top. And then same with the AI score, we say ctx.fillText, then we take in the second value, and then we want that to be, rather than canvas.width divided by 4, we're going to say 3 times the canvas width divided by 4, and then 30 pixels down from the top. And then once that's done, we can trigger this move ball function. So let's save that and then move back over to the front end, give that a refresh. So padding is not defined. Game.js 32. So 32 paddle, paddle, padding. That's my bad. Save that and refresh the front end. So when we refresh, you can actually see we've got both paddles on one side. I'll quickly go in and fix that. So here in the user paddle, we want to remove this here and just put 10. So the user paddle x will be equal to 10. So that's to make it 10 from the left. If we refresh the front end now, there we go. We can see that we have the paddle on the left, which I'm controlling, and the paddle on the right, which the computer is controlling. And you'll see the ball speeds up with every hit as well. So it makes the game a little bit more challenging with every hit. There we go, we can see the score's gone up. That's us playing against an AI. Let's say we want an AI to play against an AI. So to do that, let's first of all remove the event listener for the canvas. So the mouse no longer moves the paddle. And then where we have our AI logic, we want to create a new variable called let user target y, and that's going to be equal to canvas height divided by 2. And then we're going to take this content out here, and we can replace this with adjust AI target, and then we're taking the AI paddle, so AI paddle, and then we're going to say move towards target. That will take in the AI paddle again. Then we can do the same for the user AI logic. So function user AI logic. And that will be the same, but rather than the AI paddle, we're going to have the user paddle in there. Then we want to alter the adjust AI target. So let's get rid of the content inside here. Just going to put a space above there to make the formatting a bit better. I'm going to say if the ball.dx is greater than 0, and the paddle is equal to AI paddle, or the ball.dx is less than 0 and the paddle is equal to the user paddle. Then inside of there, what we want to say is the paddle.target y is equal to ball.y plus math.random. I'm going to times that by 60 and then times that by 30. So the same as it was before. But this time we're adding ball.y onto there. And then we need to create this new function that we have here, the move towards target. We'll say function move towards target, and that's going to take in the paddle. Then here we're going to say if the paddle.y plus the paddle.height divided by 2 is less than the paddle.target y. We want to move the paddle. Then that's going to take in the paddle, and that's going to move the paddle.y plus the paddle.dy. Else, what we're going to do is we're going to minus that value. And then we need to just update this update function here. So here we have AI logic. Now we want to have in the user AI logic too. So we can click save on that, jump back into the front end, refresh. So paddle is not defined, line 104. 104, there was a typo. Where are we? There. Save that, back to the front end, refresh. Paddle is not defined. Ah yes, the adjust AI target needs to take in the paddle in the top there. So here you can see that the AI is just moving up and down. Let's fix that. User target Y, that should be a capital Y. Okay, so the issue was inside of the adjust AI target, here the paddle.target Y is equal to ball x.y plus, this wasn't actually inside of a brackets. So it was throwing off an error because it was doing ball Y plus math.random, and then it was timesing those values by 60 and then minusing 30 off of that. So it'd always go to the bottom. Also at the top, we need this user paddle.target y equals canvas.height divided by 2, along with the AI paddle one we created in the first game. So once we've done that, when we go to the front end, we can now see that the AI paddles on both sides. So my mouse is completely still. We can see now that the AI is playing itself. Thank you for watching. Please like and comment on the video. If you're having issues with this, leave a comment and I'll help you as much as I can. In the next members video, we're going to look at Maze Solver. So this will introduce pathfinding into mazes. It's allow us to implement the A-star algorithm. It's also going to show us how an AI can automatically find its way out of a maze. I'll try and create that one so it's animated so we can actually see what it's doing rather than just giving us an instant answer. And what we can do is we can speed that process up and just feed it loads of maps at a time, randomly generated maps, and hopefully it will just keep finding its way out and we can see that working. Once again, thank you for becoming a member, and I'll see you in the next video.